So once again, welcome everyone here to the Liberty Science Center's Facebook page for our fourth edition of Planetarium Live. My name is Andrew Bundus. I'm one of the Planetarium educators at the Liberty Science Center. And while I am not able to talk to you directly from the Jennifer Chalsty Planetarium, I'll be talking to you instead from my apartment. Today we're going to be talking all about exoplanets, kind of how we find them, what they are, how many there are, and talking about how we're going to hopefully one day find a planet that maybe we could live on or that some other kind of life could live on. Before we do begin, just a few very, very quick things. Later on today at 6 o'clock this evening, we're going to be hosting a trivia here on our Facebook page. That's at 6 o'clock tonight. This trivia aimed at adults. And then tomorrow morning at 11:30 a.m., we are going to be hosting trivia aimed toward kids and families. So we do hope to see you there for that. We'll also be back right here on our page next Thursday at 1 o'clock, talking to you also more about some things you can look for in your nighttime sky during the month of May. We'll be here every Thursday at 1 o'clock doing these. But today's topic, again, is going to be exoplanets. So if you have questions while I'm talking, you can feel free to write them in the comments section. I'll try to answer as many of them as I can during the presentation. We also have a couple of staff members who are going to be answering questions as well in the comments. I'll also be hanging out after I'm done, answering more of your questions. So yeah, we'll go ahead and get ourselves started. So we're talking about exoplanets. So let's begin with our very own solar system. So this is a look here at our own solar system. We've got the sun right over here at the center and 8 planets. So these are the 8 planets of our solar system. Now, any other planet we find other than these 8, we refer to as an exoplanet. Any planet that is outside of our solar system, we call an exoplanet. So when you hear that word exoplanet, it just means a planet that orbits a star that is not the sun. So that's really all that an exoplanet is. Now, before we talk about exoplanets, let's kind of get a real quick refresher on how our own solar system is built up. So again, we have our 8 planets. The sun at the center. We divide our planets up into 2 main big groups. We divide them up into the gas giant planets. Those are the outer 4 of our planets. That would be Jupiter, Saturn, Uranus, and Neptune. Now, those 4 gas giant planets are the largest 4 planets in the solar system. The largest of them is Jupiter, which is so big that we could fit our own planet Earth inside of it over 1,000 times. So these gas giant planets are really, 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 really big, but still not as big as the sun. We've made them look a whole lot bigger here so we can kind of see them a little bit better. But then moving away from those outer 4 planets into the inner part of our solar system, that's where we find the Earth and the rest of the rocky planets of our solar system. So moving closer to the sun, we find the planet Mercury. We then find Venus, our very own planet Earth, and planet Mars. So these are the 4 inner rocky planets. And the 4 rocky planets are all smaller than the gas giants, which are outside of the solar system. And that's the case we find with exoplanets as well. Gas giants, exoplanets, are bigger than the smaller rocky planets. And, well, look at our solar system. We find 8 planets in our own solar system, which is great. But if our solar system has 8, well, maybe planets are pretty easy to find, right? If we have 8 of them, what about other stars? We do know today that other stars have planets, exoplanets. But finding exoplanets is very, very challenging. So let's look at this star right here, very, very faint, hard star to see, or really any star in the sky. If this star had a planet orbiting around it, how would we know? Kind of zooming in on a little bit here. But if this star had a planet, how would we know? We can't really see it with our eyes, and because stars are really bright. and planets are small and very faint. Even zooming in with a telescope, getting a really, really close look at a star, we still can't really tell if there's a planet here. Planets are just too small, and they're not bright enough to be able to see on their own. So when we find exoplanets, we have to find them indirectly. That means looking for evidence of them, not seeing them on their own, but looking for evidence that they are there. Now this star we've zoomed in on right here is a star by the name of 51 Pegasi. 51 Pegasi. And when we look at 51 Pegasi, we don't see a planet. What we do see, though, is the star changing a little bit. We notice a very, very small change in its color. We notice this star get a little bit red, a little bit blue, a little bit red, a little bit blue. Now I do want to mention, the star does not change this much. It's a very small change that we are exaggerating so that we can see it a little bit more easily. But it's a very, very small change. We notice light coming from this star, 51 Pegasi, changes. It gets blue and then red and then blue and then red and then blue and then red. It changes a little bit. It turns out that is happening because that star is being pulled on and tugged on by a planet. We've got 51 Pegasi right here, orbited by another planet. This planet is so massive and so close to the star that it's actually tugging on it. It's making the star itself move. Kind of makes it wobble just a little bit. Now, that shifting of the star from red to blue and red to blue and red to blue happens because this star is moving. When the star moves away from us, like it is right now, its light gets a little bit redder. And then when it starts to move toward us again, it looks a little bit bluer. Then it moves away from us, it looks a little bit redder. Towards us, it gets a little bit bluer. This is called a red shift and a blue shift. Anytime something is moving away from us, its light looks just a teeny tiny little bit redder. When it moves toward us, it looks a little teeny tiny bit bluer. So this is called the wobble method, or the radial velocity method of discovering exoplanets. We're actually watching the planet, the exoplanet, tug on its parent star, causing them to kind of orbit each other almost. It's really cool. And this method is really great. In fact, it is the first way that we discovered exoplanet here. 51 Pegasi b is the name of the planet, orbiting a star that is like the sun. And this discovery was made way back in the year 1995, and it actually won a Nobel Prize in 2019 for this discovery. It was the first exoplanet we found that orbited a star that was like the sun. And as great as that method is, and it's really useful, it has its limitations. For a planet to tug like that on its parent star, it needs to be really massive, which means using that radial velocity method, we can only really hope to find really massive planets. Planets that are like Jupiter or like Saturn, really, really big planets. So if we want to find smaller planets, rocky ones like the Earth or Venus or Mars, we need to rely on a different method. And the other way that we find exoplanets is looking for something called a transit. Transit. So, what we have here is a star being orbited by a planet. Okay. Down here, we are graphing the brightness, the light that we're seeing coming from this star. So I'm going to let this planet keep on moving. It's going to pass in front of the star, and we'll see what happens to the brightness that we measure. All right, so when the planet passes in front of the star, we notice the amount of light that we see from this star drops by just a little bit. Just a little drop in the brightness coming from the star. The planet will keep on going. Again, we see the planet pass in front of the star, and it gets a little bit fainter and then brighter again. The planet then keeps on going around and around and around and around. What we're seeing here is the planet actually blocking some of the light that's coming from this star. That's called a transit. So to find a lot of exoplanets, this is what we rely on. We rely on looking for a planet to block a little bit of light coming from its star. Using this method, we're able to find much smaller planets, planets that are like the Earth, like Mars, or like Venus. So once again, that's called the transit method. Now, making those measurements is really, really, really difficult to do. You need some pretty advanced telescopes to do it. And for about 9 years, we used what's probably my favorite telescope ever built. This is the Kepler Space Telescope. The Kepler telescope was launched way back in 2009, and it had one job alone, and that was to look for exoplanets, to look for transits. So Kepler looked at just one part of the sky. It looked at 2% of the sky, just this little tiny window into the universe. It looked through this, looked at hundreds of thousands of stars, looking for a little dip in brightness, looking for a little tiny transit coming from a planet. So it spent 9 years doing this, and it has taught us so much about the universe. Unfortunately, though, Kepler did run out of fuel about 2 years ago, and its mission is no longer active today. So Kepler is no longer active. But it did teach us a lot of what we know today about exoplanets. It found over 2,000 exoplanets on its own, 2,000 of them. Now, even though Kepler is no longer active, we are still launching new telescopes to help us study exoplanets. And about 2 years ago in April, we launched this telescope right here. This is Tess, or the Transiting Exoplanet Survey Satellite. And Tess is looking to do the exact same thing that Kepler was. It's looking at stars, looking for those little tiny transits. Now, all this blue you're seeing here, this is the field of view of Tess. This is where Tess is going to be looking. It's going to be looking at not 2% of the sky like Kepler did, but at about 90% of the sky. It's studying hundreds of thousands of stars, hoping to find exoplanets orbiting around them. It is incredible. Now, Tess was launched about 2 years ago, so it's been going for a while now. It has already found almost 200 exoplanets on its own, and maybe about 2,000 or so that we think are probably exoplanets, but we need to do a little bit more follow-up on. So Tess is kind of our next, our current workhorse in our search for exoplanets. Now, I've seen the question a couple of times now in the comment section about how many exoplanets have we found. That's a really, really great question. Now, between Tess and Kepler and other telescopes based on the Earth, we don't just use space telescopes, we use Earth telescopes as well. Humans have so far today found a grand total of, actually let me refresh the page so I have the exact correct number. A grand total of 4,151 exoplanets. 4,151. So I've drawn up now a bunch of these little yellow colored diamonds. These are all exoplanets. These are the locations of all of the 4,151 exoplanets that we have found. Think about the number, 4,151. The first one we discovered back in the early 1990s. And now we found almost 4,200 of them. We found so many of them. And every exoplanet is very different, right? Not all planets are the same, just like how no planets in our solar system are the same. Once we find evidence of a planet, we then like to keep on studying that planet to learn a little bit more about it. And in just a moment, I'm going to take you to one of my favorite planets in the galaxy. Maybe my favorite? I don't know. At least in my top 4 planets in the galaxy. It's a planet by the name of HD 189733b. Just in case you missed that, this planet is named HD 189733b. It's a mouthful. Now, this planet is fascinating. It is about half the mass of Jupiter, but it orbits very close to its star. This is its star over here. It orbits very close to its star. It's actually closer to its star than Mercury is to the sun, which is crazy to think about. Because it's so close, this planet is about 1,300 degrees Fahrenheit. 1,300 degrees Fahrenheit. That's hotter than any planet in our solar system. But that's not the only cool thing, or hot thing, I guess, about this planet. It has winds in its atmosphere that are about 5,000 miles per hour. 5,000 miles per hour. Hurricanes on the Earth with those really fast winds never get above 200 miles per hour. Then this planet has winds that are over 5,000 miles per hour. But not only that, when we study this exoplanet very closely, we can measure what its atmosphere is made of. We find its atmosphere is filled with little tiny pieces of glass. Yeah, so it's filled with glass. This planet actually rains glass. Some of it's molten glass. So, this planet is really wild. We find so many interesting worlds like this as we look around. This is a planet where it rains glass. How cool is that? Now, as wonderful as that is, this is not a planet that we are going to be able to go and live on, right? I don't know about you, but I do not want to spend any time on a planet with glass blowing around at 5,000 miles per hour. That does not sound like fun to me. So we're not going to live on this planet, of course. But what does a planet need for us to be able to actually go and live on it? What does a planet need? Well, on the Earth, we know what life on the Earth needs. And one of the things that is key to life on the Earth is the size of the Earth. So when we study all of these 4,000 plus exoplanets, the first thing that we look at to figure out whether we want to look at a planet more to learn if it can have life on it is to figure out how big that planet is. If a planet is too big, like all of these ones that we've marked in red now, those are planets that cannot support life. They are big gas giants. They're like Saturn and Jupiter, Uranus, Neptune. They're not places that we're going to live. So over almost 3,000 of the planets we found so far have been like this. They've been too big. They've been gas giants like Jupiter and Saturn. But we are learning more and more today is that there are still a lot of planets out there that are about the size of the Earth. They're rocky planets. In fact, we found about 800 or so planets that are around the same size as the Earth. This is actually really cool here. All these little blue dots, they're planets that are around the size of the Earth. Anywhere from like twice as big as the Earth to and down. And this is like really cool here. We see this very dense group of planets. This is where Kepler was looking. So that's all that this really, really big, dense group is over here. Now, for us to live on a planet, we need to know more about it than just how big it is, right? So life on the Earth needs a bunch of different things, but really to survive, just at a very base level, life needs just three things. Okay? Life needs water, life needs energy, life needs oxygen, air to breathe. We assume usually oxygen for any living thing out there. So for us to find a planet where humans can live, or other life can live, we need to find a place that has those three things. That has some kind of energy that will be coming from its star, or food on the surface, depending on what you like to eat. We need to know it has water, and we need to know it has oxygen. So we're going to fly to, we'll say a candidate to be an Earth-like planet. It's a planet named TOI 700d. So, the star the planet orbits is about half the size of the sun. It's what we call a red dwarf, the most common type of star in the galaxy. This is a red dwarf. It's orbited by three planets. Okay, it's orbited by three planets, which are named TOI 700b, TOI 700c, and TOI 700d, which is way out here. So, Planet B, is what we call a potentially habitable exoplanet. Okay, so it's potentially habitable because it is about the same size as the Earth. It also lives at the right distance from its star. So this big green ring that we've drawn here represents this star's habitable zone, or you'll sometimes hear it called the Goldilocks zone. This is the area around this star where the temperatures are not too hot, not too cold, but just right to form liquid water. So any planet inside of this is simply too hot. It's too close to the star. It's too hot. It can't have liquid water. Any planet outside of this is going to be too cold. It can't have liquid water because it would all be frozen. So for a planet to potentially have water on it, it needs to live within the habitable zone, or the Goldilocks zone. And this planet, TOI 700d, lives right within that habitable zone, which is really cool. Now, the planet itself is around the same size as the Earth. Now, it's not exactly the same size as the Earth, but it's close. So maybe this is a place that could have life on it. Now, I do want to say really quickly, this is not a real picture of this exoplanet. We cannot take real pictures of exoplanets with this much detail yet, but this is us using our imagination, thinking about what would another planet with life, with water on it look like. Maybe it looked like this. We don't know. So this is what we're really trying to do, to nail down, is can we find a planet that is like the Earth, that lives within the habitable zone of its star, that is rocky like the Earth is, and that has water on its surface and an atmosphere maybe with oxygen in it. Now, I do have some, I don't want to say bad news, but just to kind of bring down our expectations a little bit. These planets are really hard to study. This planet alone is a few hundred light years away. And we are just now getting to the point where we can begin to actually study the atmosphere of this planet. We haven't really studied it very much yet, but we're just getting to the point where we're going to be able to. It's not enough for a star or for a planet to just be within the habitable zone. Oh, and actually, I just see a really good question here from Laura. Why do planets have such crazy names? So why is this planet called TOI 700d? That's a really, really great question. So scientists like to name things based on the mission or the project that discovered them. That's one way that we name things. 700 is usually a name for kind of the number for which order it was found in, and then the letter. So TOI 700d, the D means that it is the third planet from the sun, or from that star. So all these planets have such strange names right now because that's how scientists name things. We like to kind of catalog them in the same way. Now, eventually, as we learn more about these planets, if we find out it is just like the Earth, then we'll give it a better name. And TOI 700b. But yeah, exoplanets have very strange names just because that's how scientists name things. That's how we like to catalog things. Now, I mentioned a moment ago that just being inside of the habitable zone is not enough to have life. This is our own solar system. We've got the sun, we've got our 4 inner planets, Saturn, Uranus, Jupiter out there as well. Green ring is the habitable zone around our own sun. So the Earth lives within the habitable zone, as we would expect. We live here, so it has to be. But also Venus lives within the sun's habitable zone, and Mars also lives within the Earth's habitable zone. But neither of those planets have life on them today. So just because a planet lives within its habitable zone does not mean that it definitely has water or it definitely has life. A planet needs to have lots of other things too. A planet needs to have the right kind of atmosphere, like the Earth does. It needs a lot of other things for it as well. So the first step in our process to finding a new planet that humans can maybe live on is first finding planets that live within these habitable zones. But it doesn't guarantee that it's a place that life live on or a place that has water. It's just our first step, the first of a few steps. So the next step that we need to do is to figure out whether or not planet even has water for sure. We need to confirm that. We need to study its atmosphere, and that's something that we are just now only barely getting started with studying. This is kind of the next leap forward for us as astronomers, is being able to then study the atmosphere of these exoplanets. So we've kind of been talking about in some really big terms and some more focused terms here. A question that I've seen a few times, a question I get asked all the time, is are we going to find a planet in the Milky Way or in the universe with life on it, or that we could live on? That's a really good question. We don't really know yet. But let me give you just kind of a big picture, kind of top-down look at what we've found so far. So this is the Milky Way. This is the Milky Way galaxy. It's a wonderful place. We live right here at the center. We again have all these little tiny yellow diamonds and dots that are representing the planets that we have found. This is everywhere we found a planet so far. Okay. This big cone up here is where Kepler was looking. Other missions have looked in other places. So we found over 4,000 exoplanets. We've really only looked pretty close to home. We haven't begun to look way over here in this part of the Milky Way, or way over here. We haven't really done that yet, because this is still very new science. So we're learning more about exoplanets every single day. It is the fastest moving field of astronomy, and it's changing all the time. We're finding new exoplanets every single day. And in the Milky Way alone, just our own galaxy, there are about 200 billion planets in our Milky Way, we think. We just need to go and find them. So with things like Tess, like Kepler, with other missions we're going to launch in the future, we hope to do that more and more and more. But today we found 4,150 exoplanets, and in the future we hope to find tens of thousands, if not hundreds of thousands more. And one day, if you ask me, for my opinion, I think we will find another planet, whether it's in the Milky Way or not, we'll find another planet that life could potentially live on. There's just too many options out there, too many planets out there. So yeah, if you come away with anything from this, it is with excitement. This is such an exciting field of science right now, because we really are just getting started. We've only been studying exoplanets, finding them, since the 90s. I mean, we found the first exoplanet around a sun-like star back in 1995. I was 1 year old when that discovery happened. I'm 26 now. And in 25 years, we found over 4,000 of them. It is so incredibly cool. So that's a little bit about exoplanets. There's so much to cover with exoplanets. We can't cover everything during our little presentations here, but I hope to now be able to answer some of your questions. But I hope we have all learned a little bit more about exoplanets and what makes them such a cool field of science. We found so many fascinating exoplanets out there. But at this point, I'm going to go ahead and start to answer some of your questions. But this is kind of the end of the formal kind of presentation part of our show. So before I answer questions, I want to thank everyone for joining us today. I had a lot of fun. I love exoplanets. Maybe you can tell. We'll be back here next week, next Thursday at 1 o'clock. I will be here talking, or one of my colleagues will be here talking about things you can look for in the May nighttime sky. But here on Liberty Science Center's Facebook page, tonight at 6 o'clock this evening, we're going to be hosting trivia aimed at adults. And then tomorrow morning at 11:30 a.m., we're going to be hosting trivia which is aimed at kids and families. And if you want any other cool science you can watch or that you can do at home, please visit our website, lsc.org, and check out LSC in the House. We have so many cool activities posted there. And more videos and more activities are going up pretty much every day. So thank you all so much. I'm going to go ahead now and answer some questions, as many questions as I can. Let's see. So Michelle asks, aren't there already found planets that are suitable for life? So we have found some planets that we think might be suitable for life. Really, at this point, the best that we've been able to do so far is to discover the size of a planet and to find whether or not it is the right temperature. That's as far as we've been able to get so far. And we found, I think, about 15 or so planets at this point that are sized like the Earth and that are the right temperature. But we don't know yet if they have water. We don't know yet if they have oxygen. That's going to be something that's going to happen in the future. So we haven't found exactly a planet that is like the Earth, but we have about 15 really good candidates to study more in the future. And we're going to be doing that. I mean, we're going to keep on looking at these planets for decades to come. So we're going to keep on learning, keep on finding more and more, but we haven't quite yet found a planet that is suitable for life, other than the Earth, which is wonderful. Let's see. So Myra wants to know, do asteroids circle around planets? That's a really good question. So if an asteroid circles around a planet, if it's in an orbit around a planet, we actually then call it a moon. And an asteroid has to orbit the sun, but if an asteroid moves into an orbit around a planet, we then call it a moon. So it does happen, but when an asteroid orbits a planet, we change its name. We change it then being called a moon. Let's see. So Lorena wants to know, when will finding exoplanets end? Well, that's a good question. Never. I don't think we're ever going to stop finding them. I mean, as long as there are people, we're going to keep looking for these exoplanets. We're never going to stop. Once we have found all the ones in the Milky Way, which will be a very long time from now, we'll start looking at other galaxies too and finding exoplanets in them. So we are really never going to stop finding them. So Kevin wants to know if the type of star that our sun is the most common type of star. So no, the sun is one of the most common types of stars. It's kind of a middle-sized star, but the most common type of star that we find, at least in our galaxy, are red dwarfs. Those are stars that are smaller than the sun and are red. So the sun is not the most common type of star that we find that would be a red dwarf. Let's see. So Sophia wants to know, how does a planet rain glass? Which is a really good question, and something that we're still trying to figure out exactly how that would happen. So let me actually bring us back to a look at that exoplanet that we talked about earlier, where we said that it rained glass. So so here on the Earth, we have things in our atmosphere. We have gases in our atmosphere. We have oxygen, we have nitrogen, which make up our atmosphere, lots of other things. This planet just so happens to have in its atmosphere the chemical components of glass. So this planet can rain glass because it just has a different makeup of its atmosphere. It's got little particles that form into glass. And we don't know exactly how this planet formed into having glass in its atmosphere, but it did, and it is so cool. Even looking at planets in our own solar system, a place like Jupiter can have some really crazy rains as well. It can actually rain and snow methane on Jupiter and Saturn. We think it's possible that we found exoplanets where it rains diamonds. We think maybe even Jupiter can rain diamonds. We haven't confirmed that, but it's certainly possible. We found some evidence for it. So every planet has its own unique kind of atmosphere, and some of them rain glass, some rain diamonds, some we hope rain water, like our very own Earth does. It's a really good question. Let's see. So Vonda asks on behalf of a first grader, how many stars are there in our solar system? So in our solar system, there is exactly one star. There is one star in our solar system, and that is the sun. Now, other than the sun, there are 8 planets. And there's some dwarf planets like Pluto, but in our solar system there is one star. But there are 8 planets, lots of things like asteroids, there's other things like dwarf planets, big comets, but just one star. Let's see. Jennifer asks, can 2 planets be connected in a way without being just a single sphere? So can 2 planets be connected in a way without being just a single sphere? So could we like combine 2 planets together without them being like a sphere? That's a really good question. There's actually a lot of mathematical models out there, but we think for the most part, all planets, when they come together, they end up being pretty much perfectly spherical, almost exactly spherical. That's just how gravity kind of pulls stuff together. Now, if I'm understanding your question correctly, you're kind of asking if like 2 planets could like exist together close to each other. We don't, at least I don't think so. If 2 planets kind of crash together and combine, they just form into one big planet. Over time, they kind of join together into being just one planet. Let's see. So Ryan wants to know, if there are so many planets out there, why is Earth the only one that we can live on? That's a really, really good question. With a couple of answers for you. So right now, we don't know of any other place that is like the Earth that we can live on. We just haven't found that next planet yet. But the other part of it is just that other exoplanets are just so far away. It would take us thousands and thousands and thousands of years to travel to another exoplanet right now. So even if we today found a planet that looked exactly like the Earth, that was like an exact copy of the Earth around a different star, we'd have a hard time traveling there today. But who knows what we're going to develop in the future with our space travel technology. It could be in 100 years we develop a way to travel through space really quickly, and we can travel to these exoplanets soon. If you've ever watched like some really cool science fiction shows, like if you ever watched Star Trek, that's what they do in Star Trek. Who knows if in 200 years we're going to be able to travel like they do in Star Trek by just jumping around the galaxy. Be pretty cool. Who knows? But for now, we haven't lived on another planet other than the Earth, because we haven't found one yet that we can live on, and they're just so far away we can't really get there quickly enough. That is really, really cool. Let's see. Okay, so Amanda also asks, how do we know that it rains glass on that exoplanet? It's a really, really good question. So we can measure the kind of the chemistry that is, and the type of chemicals that are in the atmosphere of that planet. And when we do that, we find that there's a lot of material called silica, which is what makes up glass. So if you wanted to learn more about like kind of the exact techniques that we use, there's something called spectroscopy, which is how we measure the kind of the chemical makeup of the atmospheres of planets. And by studying that one, we find a lot of silica. We can then run some computer mathematical models, and it lets us know that there's that silica there, and that it would probably be raining that silica. But the first step is to find that material is even there in the first place, and that comes down to spectroscopy. It's a really, really great question. Sergey wants to know, have there been found planets in double star systems? That is such a good question. Yes, we have found planets in double star systems. So anyone who is a Star Wars fan, they open up the Star Wars series on Tatooine, this fictional planet that has 2 stars. I remember watching that movie as a kid and being amazed by that. So, well, this planet has 2 stars. This planet has 2 suns. And yeah, we have found a number of exoplanets that also have 2 suns, which is incredible to think about. We have found them. So that's not just science fiction. That's science fact. We have found planets that orbit 2 stars, which is really, really cool. So thank you. So Victoria asks, do all planets have atmospheres? So no, not all planets do have atmospheres. If we look at a planet like Mercury in our own solar system, it doesn't have an atmosphere. It's just too close to its star, and the atmosphere, if it was there before, has been blown away by radiation from the sun. So not all planets have atmospheres. We think most of them probably do, at least have some kind of atmosphere, but not all of them do, which which is a really cool thing. So Kevin wants to know if planets have to be spheres. So Kevin, as far as we know, planets do have to be spheres. At least all that we've found so far. That's just kind of how gravity pulls stuff together. Gravity just naturally forms things into spheres. Now they're not perfect spheres, but they are pretty much spherical. So at least as far as we found so far, we could find a planet out there that's shaped like a big donut. We don't know, but as far as we know so far, planets do have to be spheres. So Jen wants to know, is Pluto an exoplanet? That's a really great question. So Pluto is not an exoplanet. Pluto is what we call a dwarf planet. And we'll be talking more about why that is in 2 weeks. We'll be doing a show all about Pluto and why it's no longer called a planet. But Pluto is what we call a dwarf planet. It just kind of means it's almost a planet, but not quite. It's missing a couple pieces to be considered a full planet, but it's not an exoplanet. If it's in our own solar system, it's not an exoplanet. Exoplanets are only in other solar systems. That's a really great question, something I definitely should have clarified earlier. So thank you. Let's see. So I think I saw Paige ask a question about if there's one star in the solar system, how many stars are there in the universe? I wish I could give you an exact number, but I can give you a bit of a math problem to try and figure it out. So looking just at our own galaxy, there are about 200 billion stars in our galaxy. Okay, so there are about 2 trillion galaxies in the universe. So let's assume that the galaxy has at least around 100 billion stars in it. So the answer to your question would be, at least an approximate answer, would be whatever 2 trillion times 100 billion is. So I don't know that number off the top of my head. It's a really big one. But even just in our galaxy, there are about 200 billion stars. So there's so many stars out there. It's such a great question. Stephanie wants to know, how many planets in our solar system can humans land on and explore? It's a really good question. So the easiest planet for humans to explore, other than the Earth, is going to be Mars. Because Mars isn't as harsh as a planet like Venus or like Mercury is. So Mars is hopefully a place that we're going to send humans to visit sometime in the next 20 or 30 years. There's lots of cool projects happening right now that are hoping to land humans on Mars. Now, humans would have a hard time exploring Venus or Mercury because those planets are just they're really volatile. So Venus is really hot at 870 degrees. Mercury both gets really hot and gets really cold. And then we can't really land on any of the gas giants. So humans can't walk on a gas giant like Jupiter or Saturn, Uranus, Neptune, just because they don't have a solid surface. They're made of gas, so we can't really walk on them. So in the near future, the only other planet humans are going to be able to walk on is Mars. If we could do it safely, we could technically walk on Mercury or Venus, but that would be really hard to do just because they're such dangerous places. Let's see. So So yeah, Rochelle wants to know if it rains glass, would it be disadvantageous to humans since glass can cause harm? Yeah, that planet where it rains glass would not be a place that we ever want to send people. It's just, I mean, I don't want to be caught in winds that are blowing glass around, especially not when it's 5,000 miles per hour. So really for a human to explore a planet, it really needs to be a place that is not quite so not quite so dangerous. So a place like Mars is a good example of somewhere that is not too dangerous, so that humans could walk there with some help. But even with help, we couldn't really live on an exoplanet raining glass. Let's see. Ah, so if I could name Sophia asks, if you could name the new planet that has life on it when it's found, what would I name it? I have no idea. That's a really, I'm gonna think about that. I'm curious. What would you all name if we tomorrow found a planet that was just like the Earth around a different star? What would you name it? Because I don't know what I would name it. That's a really good question. Is it too boring an answer if I just named it Earth 2 or Earth 2.0? I'm sure you are all a little bit more clever than I am. Okay, so Trina wants to know, how do astronomers zoom in so close to stars and planets? That's a really good question. So astronomers rely on what we call telescopes. Let me bring up our one example of a telescope here. So this is the Kepler telescope, which we talked about a little bit earlier. So astronomers use these telescopes to help us zoom in on things. So you can think of a telescope kind of like a really fancy pair of binoculars, like a really fancy, incredible magnifying glass, where we're able to look through them and see very close to things like stars and galaxies. But yeah, astronomers rely on telescopes because we can't go and visit these places, at least not yet. So we rely on telescopes to kind of give us a better picture of what they look like. Great question though. Great question. So many good questions. So many good questions. So Tara wants to know, what shape is the glass in that exoplanet? We don't really know. We think it's probably just a lot of little tiny little shards, little fragments of glass. At least that's our assumption. But we don't really know if the glass has a shape to it. We think it's probably just a lot of little tiny fragments of glass. So Benjamin wants to know, why does Saturn have a hexagonal shape on its north pole? That's a really good question. As far as I know, astronomers don't really know for sure quite yet. So Saturn has a big, like, six-sided shape on its north pole. We think it's a really big storm that formed from six different storms kind of coming together. That's one idea anyway, but we don't really know. We do know that the hexagon up there is a big storm. We don't know how exactly it formed yet. But yeah, it's a really good question. And there are so many good questions in our chat. I wish I could answer all of them. Let me see. So Gwendolyn wants to know, what was the name of the planet where it rains glass? So that planet is named HD 189733b. So that's a very confusing name for a planet. um, so for the most part, stars are named based on the telescope or the mission that discovered them. So So as far as I remember, I don't remember the exact mission that found that star. But yeah, every exoplanet we find has such a crazy name, just because scientists need a really good way to catalog them very, very quickly. So HD 189733 is the name of the star, and then HD 189733b, that B at the end means it's the first planet orbiting that star. But yeah, that's a really, really good question. Scientists make very confusing names for things because that's just the quickest, easiest way for us to be able to name things and talk about them with other people. Because if I've shown you anything today, it's that I'm not the most clever, so thankfully I'm not put in charge of naming things. We've got a very systematic way of naming them. So you would name it. So I'm seeing some really cool names for what we name the planet. Utopia. Some really, really great names. Let's see. So Philip wants to know, didn't Mars used to be a hot planet instead of a cold one? Philip, that's exactly correct. Mars used to be hotter than it is today. We think actually about 3.5 billion years ago, maybe Mars would have been more like the Earth. It would have been warmer. It would have probably had water on it. But today Mars is cold. But yeah, Mars did used to be hotter than it is. What kind of evidence do we have that there is intelligent life out there? So right now, we don't have any direct evidence that there is intelligent life out there. At this point, we are mostly we're kind of speculating, and we're thinking about what if it was out there and what evidence would we have to find? Like if there was intelligent life out there, how would we know? We're still figuring that part out, but we have not found any evidence of intelligent life yet, other than, of course, us on the Earth. But we haven't found any evidence of intelligent life anywhere else quite yet. So it would be cool if we did sometime soon. Let's see. Could there be different types of animals on different planets that could have life? That was asked by Trina. So could there be different animals on different planets? Yeah, I mean, I don't see why not. Life on the Earth looks like it does because the Earth is the temperature, has the water, the air, the atmosphere that it does. Now, on a different planet, we don't know what life would evolve like there, right? So if we found life on a different planet, there's a good chance it would look nothing like life on the Earth does. It could look like anything, right? We have no idea. That's what's so exciting about this, is we really don't know what life on a different world would look like, because we don't know what exactly the planet is like. But I would bet if we found life somewhere else, I don't think it would look a whole lot like animals on the Earth do. They'd probably look very, very different than what we're normally used to seeing. Let's see. So Paige thinks that Dumbo is a good name for our maybe Earth 2.0. That's a really, really great name. Dragana wants to know, how many exoplanets have telescopes found? So far, we have found 4,151 exoplanets. So 4,151. I love being able to give exact number answers to questions. So what telescope has found the most exoplanets? So the most exoplanets have been found by this telescope right here. This is Kepler. Kepler found about 2,600, so almost 3,000 exoplanets on its own, which is really, really spectacular. Let's see. So Sue wants to know if this is recorded to watch on demand. So yes, Sue, this is going to be recorded. It's going to be published on our Facebook page in the videos tab of our Facebook page. It'll also go up probably by early next week onto our YouTube page. So if you search for Liberty Science Center on YouTube, you'll be able to find this up there as well. and Dale would name it the Liberty Science Planet. That's a really, really good name. I'll have to pass that one along to my boss. Let's see. So Stephanie wants to know, how do telescopes share pictures with the Earth? That's a really, really good question. So how do we get pictures from these telescopes? Well, telescopes have in them essentially cameras, right? They're a lot like the camera that you would have in your cell phone. A little bit different, but kind of the same idea. So the cameras inside of these telescopes take pictures, and then we're able to send that information from these telescopes back to the Earth. So yeah, humans don't look directly through these. We look at the pictures that they take with their cameras. It's a really, really good question. Let's see. All right. So it is almost 2 o'clock now, which does mean that I am all out of the time that I have here today. If I was not able to answer your questions, I know we have so many questions. I love to see it. If you have, I'm sorry if I wasn't able to answer all of your questions. But we'll be live again next week on Thursday at 1 o'clock. If you still have questions, you can bring them to that session as well. We'll be going live next week at 1 o'clock, talking all about some cool things you can look for in your nighttime sky during the month of May. But again, please check out our website, lse.org, and check out LSE in the House. It's our big collection of experiments and videos and really cool science activities that you can do at home. We're going to be live tonight at 6 o'clock with some trivia aimed toward adults, and tomorrow we'll be live with some trivia tomorrow at 11:30 a.m., some trivia aimed at kids and families. So we do hope to see you tune in for those. But thank you all once again. I hope to see you all back here next week. But have a wonderful rest of your afternoon and a fantastic rest of your day. Thank you all so much.